Hey guys, in this video I'm going to show you how to do reflections on the coordinate plane, how to reflect a pre-image and get an image. So we're going to reflect over the x-axis, y-axis, the line y equals x, and a horizontal and a vertical line. And sorry guys, but I'm going to leave out y equals negative x for time purposes. So first up, we're going to reflect over the x-axis. And when I reflect, I like to highlight my line of reflection. So in this case, it's the x-axis. So highlight that. And let's start. So when I do a reflection, I know it's a mirror image over that line of reflection. So I know that from a point like A, its reflection is going to be the same distance on the other side of the line of reflection. So since A is 2 units from the line of reflection, then the image A prime is going to be 2 units from that line of reflection. And it'll look like it was just flipped right over. B is 1, 2, 3, 4, 5, 6, 7, 8, 9 units from that line of reflection. So its image B prime is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 units from the line of reflection. And the image will be called B prime. All right, the pre-image C is 1, 2, 3, 4 units. So its image C prime is going to be 1, 2, 3, 4 units on the other side. See how that works? So there's A prime, B prime, C prime, the image. You start with a pre-image and you end up with an image. So I could label this pre-image, and this would be the image. And you can see that it's a rigid motion because triangle ABC is going to be the same, it's congruent to triangle A prime, B prime, C prime. Now let's, whoa! Let's take a look at the coordinates real quick. Let's get rid of this. Let's look at the coordinates of A prime, B prime, and C prime. The coordinates of A prime were -5, -2. The coordinates of B prime look like 1, -9. And the coordinates for C prime look like 4, -4. So let's see what happens to every x and y coordinate whenever we do a reflection over the x-axis. So you might notice that all the x values stayed the same. So when I do a reflection over the x-axis, the x values don't change. When you do a reflection over the x-axis, we notice the x values didn't change. Check out the y values. 2 and -2, 9 and -9, 4 and -4. When we reflected over the x-axis, our y values did change. They always ended up as the opposite sign. So our rule would say that any point x comma y would turn into x comma -y or x comma opposite of y. That's our rule. So you really can do this without plotting it all out if you know the rule. But people forget that stuff. Now we're going to reflect over the y-axis, and it's the same thing, except now we're going to be reflecting over this guy. So highlight it, and now let's count. A is 1, 2, 3, 4, 5 units from the line of reflection, so A prime is going to be 1, 2, 3, 4, 5 units on the other side. Same thing with B. Even though B is on the other side of the line of reflection from A, it doesn't matter. You do the same thing. B is 1 unit away from the line of reflection, so B prime is going to be 1 unit on the other side. And C, same thing. 1, 2, 3, 4 units from the line of reflection, so 1, 2, 3, 4 units on the other side. And the image is called C prime. And here's my triangle. So let's look at what happened to our coordinates. The coordinates of A prime were 5, 2, coordinates of B prime look like a negative 1, 9. And the coordinates for C prime look like a negative 4, 4. So let's come up with a rule for reflecting across the y-axis. Let's see what happened to every x coordinate. Negative 5, 5. 1, negative 1. 4, negative 4. So what happened here with all the x coordinates is those changed to the opposite sign. Oops. And let's see what happened with the y's. 2, 2, 9, 9, 4, 4. So the y's never change signs there. So what we notice is when we reflect over the x-axis, the x's stayed the same, and when we reflect over the y-axis, the y's stayed the same, and the x's were the ones that changed. Now we're going to reflect over the line y equals x, which is a diagonal line that has a slope of 1 and a y-intercept of 0. So the line y equals x, let's highlight that. It's going to start at the origin and have a slope of 1. Oops. That got pretty bad. Oh well. So we're going to do the same thing. Now let's start with A. I'm going to do this my own way, okay? Since the line y equals x is a diagonal line, I'm going to count diagonals instead of just regular units. So A is 1 diagonal, 2 diagonal, 3 diagonal, 3.5 diagonals from the line of reflection. I think that's the easiest way to do it. So when I reflect it over, I'm going to go half, 1.5, 2.5, 3.5 diagonals on the other side of the line of reflection. It's probably not the way I should do it, but it works. I'll do the same thing with point B. 1 diagonal, 2 diagonals, 3 diagonals, 4. So point B is 4 diagonals from the line of reflection, so let's go 4 diagonals on the other side. 1, 2, 3, 4 diagonals. So B prime is going to go there. And what's cool about C is sitting right on the line of reflection, so it's not going to go anywhere. It's going to sit right where it's at. So C prime is in the same spot as C. Draw our triangle. And there's our triangle that's reflected over y equals x. The coordinates, we got A prime at 2, negative 5. We got B prime at, looks like 9, 1. And I got C prime at 4, 4. So let's investigate and see what happens with every pair of xy's. So every x was in, or I guess we got to look at the pair in this case, went from negative 5, 2 to 2, negative 5. I went from 1, 9 to 9, 1. And I went from 4, 4 to still 4, 4. So you probably noticed that the x's and y's switched places. So our rule for reflecting about the line y equals x is that x's and y's switch spots. Up next, we're going to reflect about the line y equals 1. So let's do the same thing we did before and highlight the line y equals 1. Y equals 1 is a horizontal line that goes through the y-axis at 1. The way I remember this is it cuts through y at 1. That's how I know how to plot that. Cuts through the y-axis at 1. So A is going to be 1 unit away from the line of reflection, so A prime will be also 1 unit from the line of reflection. B is 1, 2, 3, 4, 5, 6, 7, 8 units from the line of reflection, so B prime is going to be 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And C is 1, 2, 3 units, so C prime 1, 2, 3 units. And there's my new triangle. Oops. Just pretend that's a good triangle. And the coordinates are going to be A prime, B prime, C prime. And it's going to be -5, 0. We got 1, -7. And C prime is going to be 4, -2. Cool. And we're not going to really have a rule for this one. As long as you can figure out how to flip it over the line y = 1, I'm a happy camper. Next. Alrighty guys, our last example, we're going to flip over the vertical line x = -3. So just like all the others, we're going to highlight the line x = -3. So that's saying where x is always -3. So where x cuts through -3 on the x-axis. So -3 on the x-axis, it's like right here. Pretend that's a straight line. And let's do it. So A is 1, 2 units away, so A prime is 1, 2 units away. B is 1, 2, 3, 4 units away, so B prime is 1, 2, 3, 4 units away. It's probably getting pretty easy now. C is 1, 2, 3, 4, 5, 6, 7 units away, so go 1, 2, 3, 4, 5, 6, 7 units on the other side. And there you go. And there's A prime, B prime, C prime. We could write the coordinates, but I think you could handle that on your own, and there's not really a rule that we need for this guy. So, that is the end. You saw a bunch of different reflections. I hope you learned something. If you didn't, tough luck. Just kidding. Just ask me. See ya.